Alrighty, well, looks like we'll get started now. Yeah, hi everybody. Thanks for attending today's installment of the Zadara Learning Series. My name is Spencer Nakini. I'm on the marketing team here at Zadara, and I'm joined by Shlomi Aviu, who is our product manager, and Donna Corey, who is a solutions architect here at Zadara. And the format of today's presentation, Donna's just going to start us off today by asking Shlomi a few questions about our current object storage, as well as asking him to explain a bit how it differs from our first generation of object storage. And then just to help kind of illustrate that, Shlomi has prepared some slides that'll allow him to give a bit more of an in-depth look at our current offering. We've blocked some time off at the end for questions, so if you do have anything that pops up, feel free to drop it into the Q&A during the presentation, and we'll try to get to it at the end. But to ensure that we have enough time, I'm going to hand over the reins to Donna so that we can all get started. So Donna, if you're ready, take it away.
All right. Thank you, Spencer. I appreciate everyone coming and joining us. So as many of you know, we have some recently released some additional things. So what we want to do is ask Shlomi some questions about our object storage. So what makes this current release different from the Gen 1 storage that many of us have used in the past, Shlomi? Shlomi, you're muted.
Yeah. I should be audible now. Hi everyone. Thanks for joining, and that's a great question. Now, in order to answer that question, let's take like 2 minutes to explore what we have or what we had in terms of object storage. So here at Zadara, object storage is one piece of the puzzle. Means that Zadara currently offers a full stack of services for edge cloud, beginning with compute, networking, and storage services. Now, object storage is only a portion of our product portfolio, and it is running side by side with our VPSA, which offers file and block services. So what are the key features that we are proposing? And actually, we are doing that for the past 7 years, give or take. So our object storage is yet another Zadara product that is software-defined. Software-defined storage for, obviously, object storage. Which is scalable multi-tenant platform that is completely private and can be deployed pretty much anywhere. Okay, it has very comprehensive and very complex, very flexible networking support. It can support public networks. It can support multiple internal networks. We don't charge our customers for egress or API accounts, and the platform as a whole is very oriented for service providers. That being said, it can be used by small and medium businesses as well, and so as enterprise grade customers. The idea behind the architecture of our object storage is having multi-tenant as a top priority. Means that while you are the owner of the object storage, you can create sub-accounts, which will have complete isolation and complete dedicated resources in terms of role-based access control and in terms of user visibility. So it is very aligned with the requirements or the needs of the modern service provider. Along with management capabilities such as quotas, such as a REST API server that is dedicated for management purposes, along with comprehensive dashboards and usage reports, and that creates a very valuable or very interesting offering for a service provider who wishes to expose or resell object storage services to their customers. Now, on top of that, from a data perspective, so data protection can be done via in two options. We have two-way and we have erasure code data protection. We'll explore these options later today. But the system is extremely flexible and extremely scalable in terms of capacity and its offering. It goes without saying, but the object storage exposes S3 API interface and S3 compatible API interface that can interact with pretty much any commodity client that uses the S3 interface, along with OpenStack Swift interface. All of these goods are wrapped with a fully managed service, means that despite it's a private offering for object storage, you don't need to take the burden of managing it. It comes with 24/7 world-class support with self-monitoring and alerting capabilities, and it pretty much takes all the hassle of managing stuff in your data center with a fully managed service. So I'm describing lots of good things, but what are they? I mean, what is back to Donna's question? What is the reason, or what is the rationale behind creating a new generation of object storage? So after working for a couple of years in the object storage domain, we realized that object storage is getting a front row seat in terms of performance and in terms of use cases. It's no longer this slow, old, aging spindle drive technology that will not perform well. It requires lots of use cases, as we see in S3, as we see in Google Cloud, as we see in Azure. I mean, lots of the machine learning, data lake use cases, analytics, very demanding backup use cases are requiring lots of horsepower and lots of performance in order to operate properly with their use cases. So performance was one thing. Efficiency, while we want to create a dedicated instance. Okay, it's not a hyperscaler. We want to create a dedicated instance of dozens of drives instead of thousands of drives or tens of thousands of drives. We need to be super efficient with our software stack. We need to be able to squeeze the lemon up to the point that we say we can get 100% of the resources that we have, and we need to do that by software and not by hardware. So with our previous generation of object storage, we said, yeah, we can scale, we can perform great, but I need to compensate somehow with hardware. We wanted to eliminate that factor. We wanted to create a real scale-up object storage platform that will allow me to serve my customers better by using the same hardware and not spending resources on scaling out when it's not needed. So that was the second factor. The third factor was sizing. Sizing is not an easy task when we talk about object storage, because we need to really understand what's happening in the background. We really need to understand what's the behavior of the actual application in order to create the proper sizing. Given it's not, the traditional IOPS count and what is the ratio between read and write, there's more to it. I mean, delete operations are way more expensive than read operations. So this needs to be taken into the consideration. And we wanted to solve that pain as well, of creating a software or creating a storage array that is software defined that can be easily sized and easily deployed and easily provisioned to pretty much anyone without the headache of sizing. And last, and that's aligned with the use cases and the application needs, consistency. The previous generation we had was eventually consistent, and that was fine like 5-6 years ago. But with modern application and modern needs, we need a strong, consistent object storage, and this is something we wanted to offer to our customers. So how we have done that? I mean, obviously, when we are talking about performance, when we are talking about sizing, and we are talking about consistency, we are talking about low-level stuff. So we had to re-architect our entire storage layer. Means that our storage stack was written pretty much from scratch to allow a very good or a highly efficient storage I/O path to provide an extreme performance, or as I said before, to allow us to saturate the existing resources up to the point that we say, okay, at that point, I just need more spindles. Okay, but I don't want to be there before, I don't want to go there before I really maximize or I really squeeze the resources that I already have. So storage interface was one thing. The second thing is a new transport layer between our internal components, between the proxy controller and the storage controller. The proxy is just the minion that interacts with the customer application, regardless if you have a backup application, if you have, it can be a CLI, okay, for the sake of this example. The proxy is the man in the middle that will receive the request from the client and will transfer that to the storage. So we have a brand new transport layer between the storage and the proxy. And of course, in order to operate in a scale-up mode, we had to create a new VC layout that will allow us to segregate the resources to ensure each controller does exactly what he needs to do without sharing the resources between two components. And that's, again, an internal decision on how to make things more efficient. So what are the main deliverables? From an outsider perspective or from an end user perspective, they will not see a change. I mean, from functional perspective, the storage array behaves the same object storage operations, same S3 compatible interface. However, the internal is brand new. So we just replaced the engine without touching the outside, the exterior side of the vehicle. So from performance, we can expect linear growth in terms of performance, and I'll demonstrate shortly how we achieve that. Simple sizing. We created a single suit that will fit all use cases in terms of specification, and you just need to specify the capacity and the data protection you need, and that's pretty much it. Predictable performance, we'll explore more about that in a second. And strong consistency, of course. As I said before, eventually consistent with S3 Guard or any other middleman application that controls consistency on the storage. This is irrelevant any longer, and storage consistency is strong consistency is part of the offer. So when I'm creating my object storage at day one, it will look something like that. This is an erasure code. This is an erasure code layout that will include 7 controllers. I have 3 storage controllers, and I have 2 proxies out of the box, and 2 controllers that are dedicated for system management. They will run basically all the management services like authentication service and GUI services, and run the health checks for the entire array to make sure everything is up and running. Storage controllers, as I said before, and it's pretty straightforward. Responsible for the I/O stack, the interaction with the physical drives, and proxy controllers. These are exposed to your application. Will receive the requests coming from the application itself, process it, and transfer that to the storage controller, which is relevant. Now, I've mentioned a couple of times about the ability to scale up. Okay, so how can I scale up in such architecture? The idea here is to leverage a proxy controller concept. Okay, so out of the box, Zadara provides an internal load balancer that will serve as a single endpoint for the object storage. So when I'm creating additional workers or additional proxy services, I'm just adding more beef into the object storage in terms of horsepower. Requests will be distributed between the proxy controllers and later be transferred to the storage layer. So what I'm presenting here is basically a stupid comparison between what we have with our what we call next gen object storage release and our previous release, where we can see a very good and healthy linear growth when I'm adding more proxies. Means that with 2 proxies, I'll start with, for the sake of this example, 1,000 IOPS or 1,000 operations per second. When I'm adding 2 more proxies, I'm doubling the amount of operations per second, and so forth by 6 and almost 8. With our previous gen, while we had the concept of scaling up, the proxy was not a great contributor in terms of boosting my performance because the bottleneck was in the storage layer. Therefore, since we rewritten basically the storage layer, proxies has a bigger weight in how our object storage scales up. So from if I want to see the bigger picture of how myself as a service provider, how I'm interacting with the object storage, so it looks something like that. The south of the slide looks exactly the same as what I've presented before. On top of it, we have the load balancer that comes out of the box, runs in one of our controllers that are responsible for system services, and that will be the endpoint that clients will interact with. Okay, again, it can be public interface, it can be private interface, it can be multiple private interfaces. This is one of the great benefits of using Zadara's object storage on-prem as a backup, as a great backup infrastructure where you can delegate each account to a specific network interface that will have visibility or exposure to object storage services. And yeah, I mean, it's ready to use out of the box. Now, if you want to take it one step further, the object storage can interact with external load balancer. Means that if you have a high-end load balancer that you wish to use, no problem, we can do that as well. You can plug your load balancer, or you can redirect your load balancer directly to the proxies controllers, and by that you can achieve better control on the object storage load, better control on security from your perspective, just to be aligned with any other web services that are exposed from your organization or from or to your end customers. That's doable as well. And from administrative perspective, we provide a full role-based access control based on the needs of our customers. So each account manager can create its own logic or its own policy on how to handle his peers or users.
Great.
Donna, back
No,
to you.
I really appreciate all that information. So how has the relationship between Zadara and Veeam changed how you and the development team looked at object storage?
Okay, so great question. The love affair we have with Veeam is an ongoing situation for the past, I don't know, 4 years, give or take, since 2019. So Zadara was recognized as Veeam ready since version 9.5, and we were one of the first to adopt the immutability concept and to allow that use case, or to leverage that use case with our customers that will be able to use immutability with their backups. I think we learned a lot from the Veeam use case, because when we look at backup traditionally, even with object storage, in the majority of cases it will not be very demanding. Okay, it will be very, I will not need to get out of my comfort zone in order to achieve that. Now, what Veeam have done, and I'm saying that in a good way, they took the vendors of the private object storage out of their comfort zone in terms of performance requirements. So for 100 terabytes of workloads, we started to see a decent amount of API requests that needs to be handled. And we need to support smaller objects, okay, in comparison to other solutions where you have a decent worth few dozens of megabytes per object. With Veeam, the normal or the default object size is round about 0.5 meg. So that creates lots of dependencies or lots of constraints on the object storage side that they need to fulfill it. Now, the reason it's so demanding is because Veeam created their software in the spirit of S3, where you have unlimited resources. Now, for smaller vendors or for vendors that are focused on private offering, that's not always the case. I mean, if you want to start small, you can, in some cases, you cannot support the ongoing workloads. Fortunately, with Zadara, we have the scale up model, which allows us to accommodate or to adjust as we go with the ongoing changes or the ongoing requirement changes our customer needs.
Fantastic. So how does the Zadara object store stack up against some of the other Veeam 12 certified providers in that storage arena?
Yeah, so that's a fair question, and I answer that question on a pretty much daily basis. But I think that answering that question in the aspect of object storage alone is not fair, because it's pretty. Again, I'm off the record, and I'm glad we are not recording this session. I'm just kidding. supporting S3 application is pretty straightforward. I mean, you can take an open source package that runs S3 interface that claims they have immutability, or claims they have versioning, or claims they have a pretty decent coverage of the S3 interface, and start working with that as my object storage. Now, with Zadara, it's not the case. Object storage is only one piece of the puzzle. As I mentioned before, it's only one product of the entire platform. Now, since we have this Swiss knife of storage solution that can pretty much accommodate every use case that is needed around backup, it's a waste not to use that and not to leverage that in order to achieve better security, in order to ensure my backups are recovered properly, in order to protect my my end users from ransomware, allow DR solution, allow test and dev environments, okay, using the same platform. So basically here at Zadara, what we do, we dedicate resources up to the CPU. Okay, we pin the actual CPU and dedicate that CPU to our customer. And the same goes with drives. Okay, we start with the drives and go all the way up. So resources are dedicated for our customer or for that existing tenant. Our arrays, our storage arrays, can interact with one another. Means that if you have deployment in the East Coast, you can interact with the West Coast and transfer and do remote replication of volumes from one way to another. Same applies to remote clone, and we'll discuss about backup to object storage in a second. So going back to my first note, object storage is one option in our buffet of services that can be leveraged in order to achieve proper Veeam environment. Now, let's take a few minutes to discover the options. So with Zadara, as I said before, you can deploy anywhere. Okay, we started with co-location around our hyperscalers data centers, and we took that concept to our MSPs locations, and we can pretty much deploy anywhere. Means that we can deploy on premise, we can deploy on public cloud, we can deploy in colos, and the good thing about it is that we can interact from one interface to another. Means that we complete or we connect the dots between the Zadara footprints around the globe. So one example, one use case example is backup to object storage. Okay, and this is not in the aspect of Veeam. Okay, that can be achieved with any Zadara storage cloud. When I have my applications will run on volumes that are provisioned from my storage array. I will write my data into that storage array. The storage array in its turn will replicate or will send my snapshots of the data to a Zadara object storage, which will store the data. Okay, this is a great case of DR or test and dev, or in case I need to distribute my data. And once I have my data running on object storage or stored on object storage, I can recover that data to anywhere. Means that the only thing I need is to run a VPSA to run my Zadara storage array somewhere. It does not have any dependencies on the original data or the original storage array in order to recover the data. That can be a great solution for a Pursman DR. Means that if I don't care about my restore objective, in terms of time, I can store my data on object storage, and in a click of a button, I instantly mount the data back to a VPSA located elsewhere, and the data will be pretty much the same. So this is a cool use case. Now we discussed about Veeam. So I guess you have a Veeam application or a Veeam server running somewhere. Again, the primary backup can be used or can be provisioned by Zadara from Zadara's storage array. It can be either block or even direct to object on site. I'm assuming you'll have a remote Veeam server instance that will pretty much do the same. Okay, I'll get a copy of my data. I will offload it as part of a scale-out backup repository for a long-term retention, and then I can create another copy of my data to an off-site and immutable location. Now, the most important bit and the most crucial thing about backup is the actual recovery. This is something that the majority, we need to be realistic. The majority of businesses are not checking that periodically, and recovery is only tested when we have a crisis, and this is wrong. So Veeam has the concept of sure backup that can be leveraged, or I think Zadara is the best companion for that, because it answers all mode of operation. It can be done on scheduled time. It can be done on demand. So you have full control on ensuring the data, or ensuring the integrity of the data. So all of the above applies or adheres to Veeam's concept of 3 data copies in 2 different media, 1 off-site, 1 immutable copy, and test of recoverability, of course, by using sure backup.
All right. So for our MSPs that are on the call, what's the sweet spot for MSPs to offer Zadara object storage to their customers?
Yeah, so the main considerations we need to take here is what is the required and projected capacity. Okay, means that do I need to start with 200 terabytes or I need to start with 2 petabytes? Okay, and on top of that, am I expecting to end 2023 with 2 petabytes? Or no, I guess I'll have a growth of 500 terabytes per month, and this needs to be taken into the equation when we consider a new deployment. Second thing, performance. What are the performance requirements? Am I going to use Veeam? Am I going to use any data pipeline that is very read intensive? What are the minimal performance requirements I need to provide? This will allow us to size the amount of proxies that we provision out of the box. What happens if I got it wrong? Okay, and what happens if I got the capacity wrong? That's not a big deal. As I said before, the system is elastic in all directions. It means that if you need more capacity, we can scale out. We can add more spindles on the fly in matter of pretty much immediately. The same applies for scaling up. Means that if I need more performance, I can scale my performance up by adding more proxies. The reasons we are taking the factors into the consideration is just to be prepared on day one. Means that if we have good understanding of what's going on, that's great. I mean, we can be very aligned to what you need on day one, but you know, life is life, and we cannot expect the unexpected. So if you need to grow, that's fine, we can provide it. The last consideration is what is the durability you need. We usually recommend to go with erasure code because it's much more durable than two-way mirror. However, we do understand that we have some limitations in terms of rack space. We want to create the minimal or the smallest footprint we can do, and in some cases we'll say, okay, you need to go with two-way mirror because it will provide the performance along with the minimal footprint that you need. So just to summarize, from erasure code perspective, we can start from the minimal of 36 drives for Veeam use cases with 67% of capacity utilization. That's the benefit of using erasure code. And two-way mirror, unfortunately, 50% capacity utilization. That's physics. That's not Zadara. And we can start by as small as 24 drives for Veeam use cases. Again, we need to understand what is the use case, and according to that, we will decide how to move forward. Once we pass that bar of understanding what are the requirements in terms of initial capacity and performance, or a bit of it, we can move forward to the actual provisioning. Now, remember I mentioned before proxies, so here I'm going to repeat that again. with additional proxies, we can expect linear growth of operations per second. Means I can serve more clients. I can serve a scaling up application that requires more horsepower from my object storage using the same resources, using the same drives. So I will not need to scale out. I just need to scale up by adding more proxies into the picture.
So we've talked a lot about Veeam today, but we also want everybody to recognize that there are additional use cases for which this platform has been optimized. So we've got people using this with Commvault. We've already got people using this with LucidLink. I've helped certify this, that is now a certified provider under Acronis. So there's a lot of places you can use the object storage. We're also starting to see some new things, as Shlomi stated, in analytics, looking at just storing of data, and really just putting all the logs and video and all those types of things out for all that unstructured data. So I didn't know if anybody else had any questions. If you want to put the questions in the chat, I will put those out, get those from Spencer. Spencer, do we have anything?
It's not looking like it so far.
Okay.
Yeah, you feel free to drop it in the chat. We also have the Q&A section if you'd like to put anything in there.
Yep. Okay. Well, if we don't have any questions, I'll give everybody a few minutes back, but I appreciate everybody's time. Shlomi, thank you so much for giving us such an in-depth discussion on the object storage platform. And thank you, Spencer, for setting all of this up. I hope you all have a wonderful day.
Thank you, Spencer. Thank you, everyone.
Thanks, everybody, for coming. Have a great day.